Hello everybody and welcome to the stream. Please follow me if you haven't on Instagram and Twitter. That's where I post most of my updates when I'm not streaming. Cool. So, welcome everybody to the stream, the Tuesday night stream. So let's start with news. Just going to make a quick adjustment to OBS, my streaming software, and then we'll be good to go. Cool. All right. So, on today's agenda, we have some updates, and then we'll jump into to-do, and then we will, or I guess, yeah, we'll do the updates, and then we'll jump into to-do. So, first up on the updates, I'm running a little free event to learn about 3D CAD, code, and circuits. You can check out this page at painlessprototyping.com. For those watching on the Twitch stream, you can check down below. There's a link. For those that are checking out on YouTube later, you can type in this website. Come check it out here. It's rapidly being updated. So what it is it's from July 6th to July 10th. I'm going to be doing a series of classes on CAD, code, and circuits. And so you can check out the page here if you're interested in it. It'll be free. Quickly updating the FAQ, things like that. So I invite you to register, ask your questions, and things like that. Hope to see you there. Cool. So update on the ordered parts. Most of the stuff was supposed to arrive tonight, or maybe will arrive. It's still got some time, so we will see on that one. Hopefully, within the next 2 weeks or so, we'll be good to go assembling this thing. Third update. We finished the last stream printing parts. So this was the CAD model. This is kind of what I left everybody with. This is what our model looks like. This is what all the printed parts in the bed looked like. Things came out decently well. So if we switch over to full screen, so we can see the parts screw in pretty nicely. It's pretty rigid, pretty firm. I took these little channels that we added last time right in here to see if the belts would fit. And they do pretty snugly, which is pretty nice. And that feels pretty strong, which is awesome. Here's the other stepper motor, also pretty nicely attached. Here is the servo. This part could be slightly designed better. Might actually revisit this guy tonight. This part's a little flexible, a little thin. I'd like a little bit more. Ooh, actually maybe not. It's thin, but it's surprisingly strong. These little angles bits that I added in the back here actually make it pretty rigid. So that's good. Yeah, and then a collection of all the other slightly more boring parts. Got our little square bit. So I guess I should actually open up SolidWorks and show kind of what these parts look like. And then, of course, the most boring parts, the cubes that hold all the corner pieces together, came out pretty nice. It looks like these are actually surprisingly strong. I printed one extra so we could do a little bit of a test to see how strong it actually is. So if I can locate the one, bear with me real quick. I don't want to accidentally break the wrong part and then have to print it again. Do I have 2 extra parts? Okay, so I have 4 of these bottom pieces. I should probably start screen sharing again. So 4 of these pieces that go in the bottom, and I seem to have printed 5 of them. And then, yeah, 3 of the pieces that go up top, so I actually printed 1 extra of them too. Whoops. Okay. Sorry. Cool. So switch back over. Wow. I'd say that's sufficiently strong, I think, to hold this together. So that's awesome. Cool. So I am mostly excited about my printed parts. So yeah, so I actually remember what this little printing fail section. So this was the collection. So that's how the prints went. We're going to want to fix those printing fails. Turn that into a little to-do on here. Cool. So first up, I missed holes for the screw heads for the stepper motor. So I believe on one of these parts, let's see. So this one you can see where the screws will fit. The screws will go up to that surface inside of there. And this one forgot them. So if we take the holes off of this, put it on here, I think we'll be good to go on this little fix. Oh, I totally have the wrong screen being shared. Apologies. Let's show that again. Okay, so what I was saying is screws will rest flat in there, and that's nice. Forgot those here, so the screws will actually be sticking out. So I had to use my drill and drill little holes. So I want to take these holes and then into this guy as well. So if we look, we want these screws, and they are M6 machine screws. Oop, not that part. We want M3 machine screws. Cool, so that's what we want. So we want to switch over to that other part. Open this up. And we're going to want to switch to this. Yes. That feels a little big. All right, because these are M. Wait, how did I do this wrong? Okay, let's switch over to that other guy real quick. So these are M3 flathead machine screws. Flathead ANSI. Oh. Wait, this is exactly what is happening. If I change it to this, it only does M5s. Oh, because this changes. Okay. We want... There we go. That looks better. Cool. All right. I believe that should... Oh, they're totally on the wrong side. That's funny. All right, so it looks like we need to flip these holes upside down. So I hope I don't lose this entire sketch. I might actually have ruined this whole part. I'm not sure how to recover from this. Okay, let me just grab up my notebook and jot down our dimensions and flip this around. Okay, because these are so confusing to set up. Actually, let's copy them from the other file because I might have botched them completely. Alright, so this feature is counter bore, ANSI metric, flathead screw, M3 loose. Okay, cool. So let's delete this. Okay, actually that wasn't as bad as I would expect. Okay, so if I switch over to Hole Wizard, and we'll position them each on these 4 points. 1, 2, 3, and 4. And reduce that a little bit. That looks good. Cool. That feels good. Awesome. That is to be wait, what did that fail on? Interesting. Oh, I guess that would make sense. Those holes are now missing. So make this circle. Make those with our new holes. Wait, how did I put them on the wrong side again? I thought I just switched this to the other side. Okay, clearly I'm impressed by that. Oh, okay. The Hole Wizard on this side. Hopefully we still get access to these points. We don't. Okay, so we're going to have to select these and convert them so that they're also on this surface. Perfect. And we don't need them any more than for help, so we'll set construction so we can use them for other things. And now we can do our positions, if it'll let me. Flathead. Alright, can we position it now? Perfect, okay. Wait, what? Where did our sketch go? Let's try this again. Cool. So now, if it's gonna, yeah, I know that's a point. Let's try this again. Perfect. 1, 2, 3, and 4. Cool. And it's going to break our model again, and we're going to have to fix that mate that is now not valid. Whoop. What is it mating with? No, not the face. This hole. Perfect. Let's... Okay, that looks better. So that's the one thing on our to-do. And then enlarge servo motor holes. Yes. So, on this part, I made these holes way too small, so I had to drill those. So, let's get our calipers out and just take a quick measurement. So maybe 2.5, and they are 2. Okay. Bump you up 0.5 millimeter, and that should be good enough for our screw. Bump this up 2.5. Cool. So I'm not going to reprint these parts. I was able to recover with my drill. The holes, just drill, larger holes. Better to always make your holes smaller than larger. Yeah. Perfect. Printing fails fixed. This I'm going to save for another time. So yeah, let's review G-code. Let's learn about G-code. So, what is G-code? I'm going to give a little shot at doing a new thing where I do a little bit of drawing. So yeah, let's just make sure we're up and ready with this. Hello. Cool. All right, so G-code is a series of instructions to do prints. They generally come in the letter G. Oop. The letter G, followed by some numbers, so like 1, and then a series of stuff after it relating to that command. So if we go and we look at the G-code wiki, so I'm kind of right now, I did a previous project into the exploration around writing code for, sorry, so I should step back a little bit first. So all plotting machines, all CNCs, all 2D plotters, all 3D plotters, generally, if you want to get software off the shelf that makes them work, you want to use G-code or a tool that supports G-code. And G-code is a programming language for controlling devices. So as an example, I read through this all. It looks a little bit intimidating, but I basically was just looking for some basic settings. So all I really wanted to do was to be able to home. And so home is a command where it says walk your motors until they get back to a 0 point. So if you kind of think of like, so if this is our printing bed, let's just undo to get that out of the way. So this is our printing bed, and we say that this is like 0, 0 over here, and then in this direction is X, in this direction is Y, and your plotter head is here. You want to process such that it knows how to go back here to 0 in one dimension, and then back 0 in the other dimension. And so if you look here, this is achieved by moving this along here until it hits, this is basically a switch, an on-off switch. When it taps here, it can send a signal saying that we are reached the 0 in this dimension, and then go here and hit this other switch here and hit the 0 in this other dimension. That's because these kind of simple circuits, they don't have memory. They don't have a way to store information when you turn them off. So if you finish printing, so you write something and you're all moving about, and then it stops here to finish. This is where the pen attaches, by the way. If it stops there, the machine shuts off, it turns back on. It doesn't actually know where 0, 0 is, where the origin is. So if it assumes this is 0, 0 and it starts printing, it might end up way over here, and you don't want that. So the initial process when anything starts up is to 0. It's called the home. So it'll slide over here, knock it until it's 0, knock it until it's 0, and now it has a point of reference from which to do all of its drawing. And if you set a max X and a max Y value, it can never actually come off the rails. If you say, perhaps say this is like 300, 300, and you can tell the printer never to print past 300, 300, and it'll know that this is its domain, is this area within here. So first command, home. And so we come in here, we can see that G28, why am I missing the, there it is. G28 move to origin or home. And so this command will take a series of information, so x direction, y direction, z direction, and you can see those values, or sorry, yeah, those as inputs. So G28xz will home the x and z axes. Since we're doing a 2D plotter, we don't actually care about z. Maybe actually we do. Maybe we could say z is having the pen lift itself up off the paper, and x and y will be, so this could be x, this could be y, this could be our home, and then this little motor here, when that lifts up, that'll be our home for that. And that could be our starting position for all the other code that we do. So home is the one important command. And the next one is move. So we just want to move about. We want to be able to move the stepper motors in the x and y direction. We want to be able to move the pen down. And that can be done with the G0 command. And so basically how I found these is I just kind of read through this list and was like, well, luckily most obviously G0 and G1 move very simply, placed right here. And we can use those is G1, we can pass it X, Y, and Z positions. These other settings are optional since we are not doing a 3D printer. For example, we're not going to need to extrude anything because when you extrude plastic, that's that setting, but we don't need to do that. Or if you had like a laser cutter and engraver, you could set various settings, but not what we're working with. So we are just working with X and Y and maybe the Z. Z could actually be as simple as just like on, off. So on could be like fully down and off could be fully up. So really just two states for the Z direction. Yeah, and that's about all I found to be useful in here. Settings like loading filament, I don't need. Settings like Wi-Fi, don't need. Setting a password, yeah, none of these are really useful. Fans off, I don't need fans for a pen. But maybe in the future if I do, I don't know, make pancakes with my plotter device, might want to do some other cool things. Don't have any SD cards. Very super simple thing that we're building. And so kind of the part of this learning experience is either to, I think first basically what I'm doing is finding inspiration in G-code, and I don't think I need most of this. And so I think my G-code is going to end up being X and Y directions and maybe just an on-off switch. And so that's kind of it. So yeah, so see like a G0 command would be like our X1, send X to 12, Y to 2 is how we use our G0 command, and then you can just send G28 to go home, and then like that'd be it. So that's kind of what G-code is. It's a series of instructions, and then you send them off to your device, and your device will just take them and run them line by line. So if we look at, let's see, what do we want to look at? You can basically open up any file that is labeled .gcode and just see that it's nothing more than a series of instructions like this. So let's see, I know I should have a few G-code files in here. There we go. Cool. So if we open this one, oh, so the other bit is these mean like ignore these lines. These are just some comments so humans can read them, but don't actually need them. Let me zoom in a little bit for y'all. Cool. So yeah, so these are all those commands that we saw. It's each of the main commands, and if we wanted to pull back up here, we could say like, oh, what's M140? And M140 says set the bed temperature. So that's like the surface upon which a 3D print would run. M105 says, what is M105? I imagine it's right here. Yeah, M105, get the temperature. M190, probably be right here. Oh, it's 190 not documented here. M190, wait for bed temperature to reach the target temperature. So, very simple set of instructions, and you could kind of walk through this line by line. And then those bits where I was talking about G1. So, starts out, we've now moved over to these X and Y positions, and now we're just, and then E, I believe, was to extrude. So this G code is for 3D printer. So the amount of extrusion between those points. So go from here to there, from this Y direction, and then like extrude that amount in the process. And so this is almost all of the instructions that we need to print out all the 3D printed parts. Which I actually believe or no, sorry, these 3 files here are all of the parts needed to print. I think this was my original bold attempt to try and print them all at once, yeah. And this has, let's see how many lines, holy moly. 323,000 lines of text to do all these files, these parts here, which are very simple instructions. Like, I mean, if you really wanted to, you probably wouldn't, but you can see it's just like, go to this X position, go to this Y position, extrude this amount. I'm not sure exactly what E2 means, but Z means like go up 0.2 in the Z direction. It's like pretty legible. So what I did is I wrote some code to try and see if I couldn't make my own G code from scratch, because basically, so everything that you see here is from a tool called Cura. And so what Cura will do, we'll take in these files. So I'll run you guys through the process real quick of, this is kind of funny that I use the 3D printer to make these parts, and now I'm going to use the parts to teach you about the 2D plot we're about to build. It's like all a weird circle. Anyway, quick question in chat. Am I an engineer, or have I learned everything in my free time? So, let's see. Of the 3 parts of this project, I'm a mechanical engineer by trade, or by education. So I spent 4 years in university studying mechanical engineering, and that was about the extent of my formal education. Only did small internships as a mechanical engineer, never actually got to be like a full engineer in mechanical engineering. And then I taught myself software engineering, and that's what I do as my day job now, and also taught myself circuitry in my free time. Still barely know what I'm doing with circuitry, just kind of winging it all. Circuitry is definitely my area of least knowledge, followed by mechanical engineering and then by software. Yeah, and it's been probably about 10 years of learning and tinkering and stuff, so it's been a long journey. Yeah, so I hope that answers your question. Cool. So let's take a simple little part. We'll take this guy. We'll open him up individually. So the files that Cura likes are called STLs, and any CAD software can save as STLs. So we've saved the plotter wheel holder, and if we go to Cura, we open it up. We can see that there is now our file moved over from SolidWorks into Cura. And if we just do the default settings that it knows about my printer, Slicing is the process of taking it and kind of cutting it all up into various layers. We can preview that. And this is our model. And we can actually step through. I might use a play feature. I wonder if it does it. Okay, so what you're seeing here, I've never actually experienced this before, but actually this is pretty awesome. So what it's doing is it's stepping through each line of code. And so if we export this real quick just to see what this looks like. Okay, so the output file, the first move command says like go here. And then it goes here, and keeps going through the X directions. And you can see they're all kind of very small movements. So that leads me to believe, yeah, so you can see. So it's, let's slide this over so you guys can see. So this sits right here. So we can see that it does like a lot of small movements there. And each one of those movements is basically just a small straight line, which is all of these. And then you can see at some point it very quickly jumps from 89 to 130 millimeters, which is like a big jump, while maintaining the same y direction. And we can see that point's right there. It's that big jump there. That's a single instruction. And you can see yeah. And then it'll go around, sorry, and then do more arcs, and then another long big jump. So it looks like down here, probably somewhere in here, it jumps again, and then keeps going. Now I can just kind of watch. I've never watched this before. It's actually pretty cool. So these are like all the settings that you say. So like, let's see. The wall thickness is like the thickness of the outer. Oh, I can't drag it out of the screen. That's a bummer. Is 2. So it looks like it's probably going to do 2 outer rings. Or 3. Oh, bottom thickness. So the bottom layer is going to have 4 of those, I believe. Okay, just kidding. I don't know what I'm talking about. I've never really sat and watched this too much, but this is actually very fascinating. And then you can watch it slowly just stack up. Oh, right. Sorry, I was talking about the wrong thing. So yes, it is 2 layers. This outer bit is just to calibrate your printer and make sure everything's printing smoothly. And then you can see it start. Whoa, this is wild. Yeah, so every single one of these is an instruction. I imagine it should actually be pretty easy to watch it kind of like, if we pause here, you'll see it as it traces the outside of the layer to just be like 4 jerky. Yeah, because drawing straight lines is very simple. And so straight lines, let's see if we can find it. This is fun. I've never really looked at this before. Okay, so this looks like, I don't know what this F300 means, but G0, whoops, would bring it up to 2.56 in the Z direction, and then it would just start printing the given layer. And then it would increase again and keep going and whatnot. Anyway, so these are the set of instructions that I use for inspiration, and I was digging around in G-code, which you can do yourself, and found it was pretty easy to read. And I was like, so thinking about it, we're going to jump over to drawing real quick. So if you had a series of instructions, you could just think of like a 2D plotter as a graph. So if you had like a really big graph, and you wanted to draw like a square box, and here's like, actually to make this a little bit easier to understand, we'll say that we have like an origin. And just for simplicity, this is where the limits of the plotter would be, this kind of dotted line up here. So if we say this is like 0, 0 right here. And then this is our max. I know my printing bed I think is going to be 400 millimeters by 400 millimeters. To draw a square, like if we wanted to draw this, we'd say, if we were drawing it with ink, so I'd say the commands that we want to do would be like, perhaps like, say like PU for pen up, and then like P down for pen down. And then we'd want, if we just stole the G command, the G0 command, and then we'd have like our X, Y, and Z. And these would be the set of instructions we need to actually just, draw an O in the middle. So if we start at 0, 0, we want to lift our pen up because we don't want to, like, if our pen was down, you just end up with something like that, and then it just draw like that, and that'd look ugly. So we'd lift up our pen, we draw it over here, and so we'd be like, we'd make sure, okay, so first of all, as I was saying before, we want a home. So as we were looking before, G28 is home. So we'd want to probably lift up our pen and then home. So we do like pen up, we do G28 to go home. And now that our pen is home and our pen is lifted up so it's not dragging across the surface, we could do a G0 command and say, go to like maybe this point right here, which would be, I don't know, 50, 50. So X50, Y50. And then we'd want to put the pen down to begin drawing. And we'd want to maybe move 50 in the X direction. So we could be, go to X100, Y50, and we'd end up with a line like this. And we'd repeat that command several more times. I'm not going to keep drawing it out, but you basically repeat that. And you'd end up with this shape. And then we'd be done. And that would be how you draw kind of the letter or the number O. Or similarly, the number 0 or the letter O. And you could think of kind of similar commands where like one might be, let's leave that all in there. One might be, let's erase what we have real quick. So one might be like, go to X50, Y50 here, and then just go straight up. Two could be like, just kind of, you can see how these series of movements start to make our alphabet. And I found inspiration in what is called a 7-segment LED, and you've probably seen these on your microwave. These very simple alphabets that are composed of 7 parts, and you can make up the entire alphabet. And so it gets a little wonky and a little weird, like S versus the number 5. Like you'd think S and 5 are kind of the same thing, but the S is missing the dash in the middle. But as a starting point, you can think of like there's 7 different little pieces that make up the entire alphabet. So if we can figure out a way to draw each of these 7 little segments, we can draw any number. So if we use like as our grid, a little template, so 8 would kind of have all 7 segments in it. So you'd have 1, 2, 3, 4, 5, 6, 7 segments. And then say you wanted to I did something to my keyboard earlier. Let's just click up here. Cool. That's good. So now if on top of 8 we'd say like this is our grid, and I'm changing the thickness so you can see it a little more clearly. So if we wanted to draw the number 4, it'd kind of be like that. So 4 would be a connection of 1, 2, 3, 4 segments. 5 would be a collection of 5 segments, 1, 2, 3, 4, 5. And then you have these building blocks. So you could have like this little contained thing, these 7 little bits, and you could say like, if we numbered them, so if we went like, so actually there's a convention for labeling them. So yeah, so A, B, C, D, E, F, and G. So if we come in here, we got A, B, C, D, E, F, and G. And then we wanted to make the number 1. We could say that, increase the thickness a little bit. To draw 1, we want to just do, it's the combination of B and C. So just B, C, you have the number 1. A, the letter A, would just be the combination of A, F, G, B, E, and C. So A, F, G, B, E, C. So now you can see where we can start to have like B equals and C equals. And then if we continue on with the numbers, we have 2 equals. Then you have A to Z and 0 to 9. And so like the instruction for A, all right, so it says fill in A, fill in F, fill in G, fill in B, fill in E, fill in C. And so if you can think, we can start to take these kind of series of instructions that we have here and map them into this kind of G0 movement commands and the pen up, pen down. So you could say that A could actually be, if we say like, if we clear all this away, clear a little bit of this away. So we take A and we drag it onto the origin. Come back and we start drawing again. You can see that our origin. Cool. Thank you for the suggestion. I'm trying out just talking tonight to see how it goes, but we'll probably switch back to science and technology. Yeah. So yeah, so you could see that 0, 0 could be like the bottom corner, and then maybe 0, 25 could be this side. And then that becomes this segment D. And so you could say like D actually equals G0 from 0, X0, Y0. So I'll do that real quick. Give a little bit more spacing. G0, X0, Y0. And then D, we'll want to draw and move. Actually, we're going to need to put our pen down. So we'll do pen down. And then we're going to move to X. Oh, I got these backwards. So it should be X25, Y0. And then that'll draw the segment D. And so now we have the segment D. And we can repeat that 7 times. Put that back in that little thing where I said to draw A, where A is equal to the segments A, F, G, B, E, and C. And then you can see how this slowly starts to build up from these kind of primitive, very simple instructions, where instead of having to think about all these kind of crazy things, D, line segment D, actually just pops in right there, and we have some kind of way to map between the two, or convert from one to the other. And so this is kind of the research that I did to make my 2D plotter, or initial explorations into 2D plotting code. I have a little quick video. I do a lot of projects. Here we go. So yeah, so this is the 2D plotter in action basically what we have is I 3D printed a part that attaches to the printer, and then wrote a bunch of G code which you can actually upload straight to your printer, which is pretty cool. Because really G code is just a collection of instructions that any machine can read, and so long as the machine has the actual physical pieces to read them, so if a machine can move in the X and Y direction, if you send it G0 commands for X and Y, it's going to know how to move about them. And in this case, since this is a 3D plotter, I was actually sending PD and PU as G0 commands with X up and down. So basically, like X0 would be touch the bed, and X5 would be like lift off the bed. And you can see it kind of drawing those individual segments one at a time, which are definitely more efficient ways to do this all. But the goal of this was not really to be efficient, but to learn. I suspect I'm going to make a lot of silly whatevers as we go through this project. Now that we move away from the physical part, the code's going to be pretty wild, I think. But I believe. So yeah, so this was the general idea of the 2D plotter, or as a 3D printer conversion. If you are curious, I invite you to hop over to, well, actually, let's see. Bear with me as we do this bit real quick. So yeah, so if you come down here, and at the bottom below, there is a link. Oh gosh, I really didn't link to my YouTube. That's funny. Okay. I will have to change that in the future. All right, so if you come over to my channel, if you can just search Travis the Maker, Travis Bumgarner, on YouTube, you'll get my channel. I have sorry, I meant to click full playlist. So I have a 3-part series, about 6 hours long of streaming on how I did that, how I coded that. So if you want to learn more, I suggest you go check that out. But yeah, so as a final step, we can actually look at kind of what I made. I believe also, yeah, if you want to check out, there's a 2D plotter from, oh gosh, I'm clicking the wrong things. 2D plotter for the 3D printer. And this is all the code. It's got actually the links to all the streams and such, and you can check it out there. And yeah, so if we cool. All right, all right. Okay. Oh my. All right, let's just close SolidWorks. We don't need this anymore. Luckily, I have more RAM coming in the mail. Oh, I don't actually want this. Let's just close out. Okay. This is another thing we don't need. All right, so this is our main function. And for those that don't know code, I'll try not to go too deep into things here. But so that mapping that I was talking about, where I said that like the letter A goes to AD or ABGEDC, that's this little lookup. So it takes in all these characters on the left side, outputs them to a set of simple instructions that we can. Each of those makes up one of the line segments that makes up the fuller character. And then here's one further where I map from each of these letters up here into a line. So 7 lines, 7 segments make up the 7-segment LED. And then where all the magic happens. So basically, we have draw character, which will draw a single letter, and it'll take in the character to draw and the starting point. And one thing I didn't really touch on here is if all of your commands are like, so let's see if we just clear out some of this. Actually, let's leave this here. So say we just finished drawing the number, letter, whatever this was supposed to be. Weird mishmash up. Anyway, if we come in here and we're like, all right, next letter, we're going to draw the number 1. And it just lifts up and it goes over to here and it goes down and it just draws. Whoop. Ugh, if I can draw straight. And it's like, here's the number 1. And then it's like, all right, let's draw 2. All right, we'll draw it there. And you can start to see that everything just kind of piles on top of each other. Not good. So what we want to do is each time we print a letter, we want to keep track of kind of the origin. And so if the first letter is here, we want the next letter to move up some amount of distance over to here and then draw the next one. So if we wanted to draw 1, you could think that the outline would be here for each letter, that little box that I talked about, and 1 would just get put here. And then again, it would increase some distance to here, maybe draw the number 2, and then we'd have kind of this, at least in one direction, a series of letters. And then at some point, let me delete all this again. Oh, that works. Let's draw it. So this is our new XY plot. So if we said like draw a number and another and another, and if our total printing area was that big to that dotted line, when we get here, basically just take that origin point that was here, because if we track all our origin points, just move it down. So this is like our character height, and then we'll move it down 1 character height, and then we can start drawing more stuff. For simplicity's sake, we're going to do monospaced fonts, and monospaced fonts, as you can see, mono space, single space, or same space. So the space of every letter from here is equal to here. We gave it some variable x, they're all equal. And then same height as well. I imagine I could write some very fancy code. Kind of with this project, it's going to be layers and layers and layers. And I think at least for the proof of what I want to do, I want to have like a single font, which I guess I've already defined as whatever font you'd call this, I guess a 7-segment LED font, and then a collection of primitives, other shapes. So like circle, square, line, maybe oval, triangle, maybe a few other primitives. I mean, because really with just the line, you can make all these other ones. Like a circle would just be a bunch of little lines, straight lines. A square would just be 4 straight lines. A triangle would just be 3 straight lines, and so on. So how many things I want to extract away? Not sure, TBD. But yeah, so we jump back over the code. So basically go and get each of those primitive lines. So say if the character to draw was A, we'd go up here, we'd look at the letter A. A is this collection of characters. So for each of those primitives, we'll draw the primitive. And then we will build up this kind of output as instructions that we'll send the printer. So just to show you real quick, if we wanted to just draw the letter A, we should have a very simple set of instructions to draw. So the A is made up of, what was it? One, two, three, 6 segments. So 6 sets of instructions. I broke them by space so it's easier to read. So this is the first line, the second line, the third line, the fourth line, the fifth line, and the sixth line. And as I mentioned, G28, always go to home. G0, just lift the pen up, drop the pen down. Bring the pen to the surface. This was actually a little bit of test code, which should be gone, but oh well. Draw the primitive, bring the pen back up, go to the next one, drop it down. And that was what's used to make the letter A. So to finish out, if we wanted to then, kind of the rest of this code is for drawing all these initial steps that I talked about, validating that the input is correct. So if someone passes in a character that the printer doesn't know how to print, it'll error out. And then keeping track of the X and Y direction, printing letter by letter, and things like that. And if we wanted to draw a really longer thing, this little function, so we'll then compile the output to G-code. If we run this, you can see that you're going to get a ton more lines of code. And you can start to see how these things get really complicated. So that, to output Travis the Maker is talking right now, 700 lines of code. Which luckily, with just 110 lines of Python, we can generate this whole file. If we had something even larger, get a lorem. So lorem ipsum is like a fake text generator. So we wanted to generate 5 paragraphs of fake text, and we wanted to print this out. And I'm going to do one moment. I think it might actually fail because I never handled periods in my, I didn't. I only handled dashes, underscores, and spaces. Okay, so it's not quite going to work. Let's just say we paste, I'm going to repeat this just for, as an example. And then if we word wrap, that's how much text goes in. And if we see the output of that, right, I forgot I added one other thing. If the text runs off the printing bed, it'll throw an error. So this is already too much text to print, and this is why it's good to have little errors. You don't want to have your printer run off the printing bed. So let's see if we can print less. I think this won't even fit either. We can try. So there's a config where we can set the height and width of each character. So this is currently 10 millimeters by 20 millimeters high. So if we made it really small, like 4 millimeters high by 2 millimeters wide, came back here and undid this, we should be able to fit this in there. Nope, that doesn't want to fit either. Interesting. Let's try and reduce these letters. There we go. So the code to write Travis the Maker is talking right now, repeated several times. Wow, that's crazy. 12,000 lines of code. And this is why we abstract things away, so I don't have to sit here and write G is this and I is all this. Cool. I'm going to take a sip of water, take a quick 30-second break. If you have any questions, feel free to queue them up in the chat. Cool. So let's see. So we've kind of reviewed G code, got on the same page. We've reviewed the code that I've written before. I just went to look outside because the rest of my parts should be arriving tonight, and I think at this point they're not going to, which is a bit of a bummer because I would have rather have taken them out and screw everything together, which would be a lot more exciting. I think I kind of at this point need to think on how I'm going to do this. So I got a whiteboard for a bit. So plan of attack for writing code. This will probably be a bit more of a not whiteboarding activity. So I'm trying to think, let's see, let's switch over to, let's call this possibilities. So I was debating making a paint program, which would just be silly. So let's see, so idea one. Or you could really think of a paint program, a CAD program, whatever. But if we open up like MS Paint, I think would kind of be the inspiration. There'd be a single color. It'd be whatever pen is attached. So say black. And it'd only have one size. So whatever size we specify. Maybe this is our pen. And then we built this in Python. And Python would maybe let us write out some text. And it'd have to be monospaced, as I talked about. And I know that one of these is monospaced. Courier New is monospaced. So we wouldn't do as fancy of letters. But there, you got Hello World. And then in the paint program, you could come in and draw a little rectangle. And that'd be another one of our primitives. And you'd keep track of this as well. And then maybe you could add some more text. Make it a little smaller. And so the code for that could be like draw a rectangle. And it would start at maybe 0, 0. Top right corner. And it would go until 200, 200 perhaps. If we assume that like from here, whoa, this is kind of wild. So it said like that. Wow, man, this is hard to draw a straight line. There to there, and there to there are 200. So we could draw like a rectangle there, and then we could have like another function that says like draw text, and say the text starts at 10, 10, so slightly down. Travis the Maker. And then we could have another function that says draw text, maybe same X position but further down the Y. And then maybe we'd want like the font size. So we could say like this is font size 10 and this is font size 20. And so basically what would happen is we'd build a little app, and when you hit print, it would take all of what you'd drawn here and kind of output it to these set of instructions. And those instructions, so kind of similar to how we wrote a little, or approved the draw text function, we could have a draw rectangle function and a draw circle function, and those would be our primitives. And then you could kind of combine those together to do more interesting things as well. which maybe next time on the stream we'll build a paint program. Feels like a crazy idea. And then you'd hit print and you would just have the 2D plotter would output what you print. Or maybe step one, maybe we call this step one. Create more primitives. And then step two, create a paint program. So this could be what we do for the next 2 streams, or longer, depending on how long it takes me to make a paint program. And I think we will do this with G-code to start. And we can test these out on my 3D printer. So like my 3D printer pen attachment still attached. We can send those primitive instructions over, see how they work, and then probably at that point it'll be time to set up the 2D plotter physically, assemble it, which will probably actually be next stream, hopefully if all the parts arrive, and tinkering with that for a few streams. And then at some point we can actually write code on the 2D plotter to take G-code instructions and plot them out. So we'll kind of write that whole part from scratch. So I think there's unfortunately not much more to achieve tonight. Gonna take one quick eye to see if UPS is coming tonight. If not, we shall call it a stream. Oh, unfortunately, package is still out for delivery. All my packages are out for delivery. Let's see. Bummer. Okay. Cool. So yeah, I think unfortunately that's where we're going to stop tonight. If you have any questions, feel free to ask now. Otherwise, we will end the stream. If you haven't gotten the chance, please check out painlessprototyping.com. Sign up if you want to come learn about CAD code and circuits, kind of what you experienced tonight, but in a more dense, jam-packed week. So it looks like there's no questions, so I will catch y'all next time.